Okay, so this is an example for defining open and closed systems, and to using those definitions to use conservation principles. For our question, we're gonna be using, for part A, we'll be just using kinematics. So a block of mass m1 travels horizontally with a constant speed v0 on a plateau of height h until it comes to a cliff. A toboggan of mass m2 is positioned on level ground below the cliff as shown above. The center of the toboggan is a distance d from the base of the cliff. So for part A, this is a kinematics problem. So they're defining our distances and heights and velocities for our kinematic equations that we will be using. So this is our delta x, and then we can set our axes. So this is the positive, we'll say the positive x-axis, x direction is to the left, positive y direction is above to the top. So delta x is equal to d, because this m1 is going to travel like this to the center of the to the center, and then it'll be a distance d from its original position. And we're saying that its initial velocity is v0, so you can say v initial x is equal to v0. So if we use our kinematic equations, so we need to have delta x equals d, and these are our initial values. So delta x equals d, v0 equals v initial x is equal to v0, and then we're not given the time, and the acceleration in the x direction for projectile is 0. So we can say delta x equals v0 times t, v initial x times t, plus half axt squared. But since our acceleration and acceleration is 0, we can cancel it out, and now we can plug in all our values. So d is equal to v0 times t, and we're trying to find this d distance in terms of all these variables. But t is not one of our variables that we're allowed to use. So this is our x direction projectile, and now we can set up our equations for the y direction. So if you see for the y direction, the block is actually going to be falling a distance of delta y is equal to negative h. It'll be falling a distance of negative h, and the bridge, you can say, between the x direction and y direction is is constant. You can't change the time for which projectile moves, and each situation for x and y will have the same time bridge across them. So we can say t is equal to, say, big T, and then acceleration due to gravity would be negative g, since we're defining the positive y direction up top, and then delta y is going to be negative h. And we can say v0 or v initial y is equal to 0, since the block is only moving horizontally initially, so it has no y component of its velocity. So now we can use an equation, delta y is equal to v0 times t, v initial y times t, plus half ay t squared. And we know delta y is going to be negative h, and our v initial is 0, so we can cancel that out. And our half times negative g, the acceleration, times t squared. So negative h is equal to negative 1/2 gt squared. Negative cancel out. So if we solve for t, we get t squared is equal to 2h over g, and then we get t is equal to root 2h over g. So we have this time now, and so we can go ahead and plug that in to our original, what we needed. So if we plug those values in, d is equal to v0 times t, v0 times root 2h over g. That's part A.